Today we're going to learn how to find independent and dependent probability and also how to find odds of a certain event happening. Recall our other situation where Jerry, Johnny, Joey, Jimmy have each purchased raffle tickets for chances to win a seat at a game at Yankee Stadium. 500 people have entered the raffle in this particular problem, and still only 2 seats will be given away for a game against the Boston Red Sox. We need to define odds, so what we're going to do is define odds as the ratio of the number of ways to find success in an event or a selection, and compare that to the number of ways that you can fail when making a selection. In situation 1, 2 tickets will be drawn in the raffle, and the first ticket holder will win a seat in a luxury suite 20 rows up from home plate. The second ticket holder is going to win that seat that's in the upper deck in the right field, near the foul pole. We're going to find the probability and the odds that the 2 of the boys that we know, 2 of our 4 boys, will win these 2 seats. On the first selection, we have 4 boys that can be chosen from the 500. Supposing that one of them is successful, then the 3 of them are still left in the raffle, and there are now only 499 tickets, and so our total probability is, it's dependent because it depends on the first selection. It is 3 out of 62,375. Now, probability is the ways to find success or be selected successfully out of a total number of possibilities. Odds, however, are slightly different. It's success compared to failures. And so the odds of winning, of having 2 of our guys win these tickets, are 3 to 62,372. In the next situation, 2 tickets are going to be drawn in the raffle. The first guy will win a seat in the luxury suite, and the second person will be winning the upper deck seat. We want to find the probability and the odds that Johnny will win the luxury seat and Joey will win the right field seat. This is much more specific. So we have 1 out of 500 for Johnny winning. Supposing that he did, it's 1 out of 499 that Joey would win the second seat. This is also dependent probability because Joey's probability depends on what happened with Johnny first, and so we would get 1 out of 249,500 that this could actually happen. The odds of this happening, success to failure, are 1 to 249,499. Situation 3, we have we want to find the probability that this time Jerry will win both the luxury seat and the right field seat. In this case, the person who wins first will have their ticket thrown back in for a second chance at winning the other seat. This is considered independent probability because no matter what happens, whether Jerry wins or not, Jerry's ticket is still available for the second drawing. So we have 1 out of 500 times 1 out of 500, which is the chances that Jerry will actually win the ticket both times is only 1 in 250,000. The odds that Jerry will win both of those tickets is 1 to 249,999. That's success to the number of ways that he could fail. Situation 4. 2 tickets are still going to be drawn in the raffle. This time we just want to know find the probability and odds. If Jimmy wins that first seat, what are the chances and the odds that Johnny, Jerry, or Joey will win the second one? So here's what we have for Jimmy winning the first drawing, for 1 out of 500. Then the 3 guys have 3 out of a 499 chance of winning after that. This is dependent probability. Once again, what happens with the 3 boys is dependent upon Jimmy's ticket no longer being in the raffle. So that's 3 out of 249,500. The odds, on the other hand, are 3 out of 249,497.